Di ko pa lalaman eh.
Ano po name?
Angelicena? Baka gumagamit ng ibang account ito.
Wala po kaming kilalang ganyan, ma'am.
Kaya nga eh, baka one of your classmate na ginamit yung account ng iba. Outside EAC eh. I'm not accepting her kasi how do we know kung she really belongs to the class? Okay, so 27 out of 41. Where are the others? So we can continue with the lesson. We are already running out of time. Mag-quiz pa tayo sa Thursday next week. Mm-hmm. 5 minutes more and we will start with the lesson. Reminding you of your simulations, ha? Ang dami pang walang simulations dito. Aquino, Blase, Batulino, Patunina, Dupa. You have to finish 8 simulations for the finals. Joseph, Katli, Magnay, Manipol, Petersen, Pineda, Sebastian, Pined, Vargas. Okay? Wala pa kahit isa. Anong nangyayari? Why are you not doing your simulations? Remember, there shall be no completion of incomplete class standing in the laboratory. You should finish the 8 simulations until the examination period. Okay? Can you do it? Pag hindi, you will not be given incomplete. Magbibigyan lang kayo ng incomplete pag wala kayong exam. What are you doing? What have you been doing? Ang daming nakalipas na holidays, you did not do your simulations. Okay, so I think we should start with the lecture now. Because we are running out of time already. We have only 2 meetings left. And we still have to finish 2 topics after Thermo Part 2, Thermo Part 3 pa. Tama ba? Thermo Part 2 pa lang tayo eh. Slide number 31. Oops. I just hope that you had a little review with regards to the topic. Okay. So some of you have already done the simulation on calorimetry. Some of you, meron na nakatapos ng simulation although we are not yet done with the topic. So I'm glad that you were able to do it. Like Mr. Borbor, Mr. Coronel, Mr. Estomo, Mr. Herrera, Jose, Pakinggan, Sinsay. So they are done already with the simulation on calorimetry. So for this, let's consider constant. We are done with constant volume calorimetry. So we have said that when you say constant volume calorimetry, it readily measures change in internal energy. Because when you say constant volume, there shall be no change in volume. So that the formula delta U is equal to Q minus P delta V. Since the volume is constant, delta V is 0, multiplied by the pressure, it becomes 0. So delta U now is equal to the heat at constant volume. So we can say that constant volume calorimeter readily measures heat at constant volume, or delta U. Delta U. Of course, always remember the formula for the constant volume. I mean to say constant volume calorimetry, that is QV is equal to MC delta T. MC delta T. Okay? Wait lang. So for constant pressure calorimetry, we started with it already, and we go back to the problem. So a student built a coffee cup calorimeter using 100 milliliters of water. 4.95 grams of solid potassium hydroxide was then added to the water. As the potassium hydroxide dissolved into the solution, the temperature of the solution increased from 23 to 34.5 degrees Celsius. Now calculate the change in enthalpy of the reaction. Let us assume that the density of water is 1 gram per ml and its specific heat capacity is 4.184 joule per gram degree Celsius. Okay, so we were able to solve for since the reaction actually resulted into the release of heat. So the calorimeter absorbed the heat from the reaction. So what happened is that we were able to calculate the heat absorbed by the calorimeter to be 5,049.8 joules. We have to consider the change in temperature from final to initial to be 11.5 degrees Celsius. So in this, we have the heat of the calorimeter is equal to the delta H of the reaction, di ba? Kasi nga nag-absorb ng heat si calorimeter, si reaction naman nag-release ng heat, kaya negative. Okay? So the the delta H of the reaction is negative. Now, this is just rounded up into negative 5.05 kilojoules. Now, that is for the heat released when 4.95 grams of potassium hydroxide was added into the water. But take note that delta H is a molar thermodynamic property, meaning it is always per mole basis. So delta H per mole dapat yung unit natin. So when we speak of the number of mole in terms of delta H, we always consider making use of the molecular mass of the compound. So gagamitin mo yung molecular mass ng potassium hydroxide in order to get the change in enthalpy per mole of potassium hydroxide. So from your periodic table, kukunin nyo ngayon yung molecular mass ng potassium hydroxide, which is actually 56.11 gram per mole. So making use of that, we have 56.11 gram per mole, and then multiply it by the negative 505 kilojoule per 4.95 grams of potassium hydroxide. Okay? So we still have a negative delta H here. So by this, we were able to derive a negative 57.2 kilojoule per mole of potassium hydroxide dissolved. This is now the delta H per mole of the solution. Got it? Naintindihan nyo, class?
Ma'am, okay lang po, ma'am. Paulit lang po ulit. Medyo naguluhan lang po.
Saan ka naguluhan, Mr. Villapando? Which one? Kasi we said that enthalpy is a molar thermodynamic property. When you say molar, the unit should be delta H per mole, di ba? And the heat that we were able to get is per gram. That is per 4.95 grams. Para maging per mole, you should make use of the molecular mass, di ba? Di ba? How do you determine the number of moles? Di ba? Mass over molar mass, N over mm. Still remember? Huwag yung kakalimutan yun, ha? Number of mole is equal to mass over molecular mass. So in order to get the number of mole, you make use of the molecular mass multiplied by the mass. Diba? The heat over the the number of mass. So N is equal to mass over molar mass. Para makuha mo ngayon yung per mole ng potassium hydroxide. Okay, Mr. Villapando?
Yes po, ma'am.
Got it? Always remember that N or number of mole is equal to mass over molecular mass. Do not forget that formula. Kinamit natin yan nung midterm, di ba? Okay? Got it? Can you not, won't you be able to open your cameras also? To meetings na lang tayo. Yung iba hindi ko pa nakikita. Can you not open your cameras? Finals na, to meetings na lang. Baka magkasalubong tayo sa sa EAC. Okay. So let's proceed. Now, summary of calorimetry concepts. Ito yung pinaka-summary. Okay. Saglit lang, paliitin ko yung nyo. Para mas malaki. Ayan. Okay? So for the summary of calorimetry concepts, okay, calorimetry is a means to measure heat transfer during a reaction. Remember that. Calorimeters minimize heat loss to the surroundings, making it possible to relate the observed temperature change in the calorimeter to the reaction occurring inside. The amount of heat absorbed by the calorimeter is the same as the amount of heat released during the reaction. If we assume no heat loss to the surrounding environment or vice versa, so meaning to say if there is no heat there is no heat loss to the surrounding, we consider calorimeters as an isolated system because there is no transfer of heat. There is no heat loss to the surroundings. They are insulated, even for bomb calorimeters. Okay? Bomb and what you call, especially bomb calorimeters. Pinerform nyo na yon yung simulation number 6, that is simulation number 6, making use of bomb calorimeters. Diba, Mr. Herrera? Nagawa mo na yon, diba? Am I right? Miss pala ito. Miss ba ito, Mr. Herrera? Herrera Marijan Allen. Hello? Nandiyan ba siya? Are you there, Miss or Mr. Ha? Please respond kung di ma-mark kitang absent dito. Kasi nag-attendance ka na eh. You are present here. Andyan ka pa ba? Hello? Hindi mo respond. Mapsisira yung record mo dito if that's the case. Okay, you have done this, di ba, Mr. Sinsay? Mr. Sinsay? You have done calorimetry already sa simulation? Mr. Sinsay? Oh, wala din? Wala pa siya? Okay, how about Mr. Coronel? Si Mr. Coronel nagawa na niya. Am I right, Mr. Coronel? Nagawa mo na yung calorimetry, di ba?
Yes po.
Okay. Ayun. Mr. Herrera, you have done already.
Lang po, sorry po, nakadata lang po.
Marhakahan
Ano po yun, ma'am?
dito. I said
Ano po?
you are done with calorimetry already. Tama ba? Sa
Yes po.
simulation.
Yes po, ma'am.
Okay, sabi ko pag wala ka dyan, may mark na yung ano mo dito, record mo.
Opo. Na DC lang po, ma'am. Nakadata po ako. Nasa labas po kasi.
Okay.
Pasensya na po.
Now, of course, when you say heat absorbed by the calorimeter, it is equal in magnitude to the heat of the reaction with opposite sign. Pag inabsorb ni calorimeter, it means to say that the reaction released heat, kaya negative Q reaction siya, which is the same as the delta H of the reaction. For an exothermic, okay, pag exothermic ang reaction, meaning heat is released by the reaction at constant pressure, it is being absorbed by the calorimeter. So tandaan nyo itong mga relationship na ito sa quiz nyo ha, at saka sa exam. So if the calorimeter is the one that released the heat and absorbed by the reaction, magiging negative si heat Qcal. So negative Qcal is equals to positive delta H reaction naman siya. Okay? Now, for an endothermic reaction at constant pressure, heat is absorbed by the reaction from the calorimeter. Okay? So, negative Q-cal, nag-release siya. Absorb naman ng reaction. So, oppositely, baliktad naman yung sign ngayon. Now, the question is, for an endothermic reaction, would the temperature of the calorimeter increase or decrease? For an endothermic reaction, would the temperature of the calorimeter increase or decrease? Mr. Villapando.
Ma'am, yung temperature ma'am ng calorimeter po ma'am.
Increase or decrease?
Ma'am, increase po ma'am.
Ha?
Ay, decrease po ma'am kasi ma'am yung heat galing from calorimeter po ma'am. So, nabawasan po siya ng heat.
Nag-release kasi ng heat si calorimeter na absorb ni reaction. So, ibig sabihin, nabawasan yung heat niya, nag-decrease ang temperature niya. Okay?
Yes
Dapat
po ma'am.
ganon. Dapat ganon. Ha? Pag nag-release ng heat, nag-decrease ang temperature. Halimbawa, class, yung ice, nag-release ng heat. Okay? Nag-release ng heat, nabawasan siya ng heat. Anong nangyari? Pag yung ice nag-release ng heat, anong nangyari sa temperature ng ice?
Lumalamig ma'am.
Nag-decrease, di ba? Kasi paano mag-freeze yung water? Pag nag-freeze yung water, ibig sabihin nag-release siya ng heat. Kasi lumalamig na siya eh. Hanggang sa mag-freeze siya. Hanggang maging 0 degrees Celsius ang temperature niya. Di ba? Di ba pag naglagay kayo ng tubig sa freezer, habang nagde-develop yung ice, tumitigas, ibig sabihin nawawalan siya ng heat. Kasi nagde-decrease yung temperature niya. Nagre-release siya ng heat. You get my point? Okay. In a constant pressure calorimetry experiment, we can measure the heat transfer for a small amount of reactant, parang yung potassium hydroxide. Then use our result to calculate the molar enthalpy. Molar enthalpy, that is delta H per mole. So ma'am, if ang ice is turning water, yes, nag-absorb siya ng heat. Diba, inilabas mo ngayon yung ice. Okay, nilabas mo si ice. Natutunaw na siya. Ibig sabihin, nag-i-increase na yung temperature niya, tumataas. Halimbawa, di ba ang freezing point ng water is 0. So pag nilabas mo na siya, nagme-melt na siya, nag-absorb na siya ng heat from the surroundings. Kasi tumataas na yung temperature niya. From 0, magiging 6, magiging 12, hanggang ma-reach niya yung room temperature na 25. Tunaw na siya. Diba, room temperature is 25 degrees Celsius. Okay? Pero malamig pa rin siya. Pero tunaw na siya. Right. So, in a constant pressure calorimetry experiment, we can measure the heat transfer for a small amount of reactant, just like potassium hydroxide kanina, 4.95 grams lang. So, that is just 5%. Then, use our result to calculate the molar enthalpy, which is the amount of heat released or absorbed by a mole of the substance. Now, the heat under constant volume condition is equal to delta U. Remember that. Pag constant volume calorimeter naman, that is delta U is equal to the heat absorbed or released. The heat transfer constant, the heat under constant pressure conditions is equal to delta H, of course. It can be released by the calorimeter or absorbed by the calorimeter or vice versa, depending on the condition of the problem. Okay? Now, we have an example. Okay, the following is a list of the specific heat capacities for a few metals. The specific heat of copper is 0.385 joule per gram degree Celsius. Gagamit tayo dito ng joule. Joule per gram degree Celsius. Okay, hindi ko ma-i-ano yung degree ha. So, yan na lang. So, the same for iron, 0.444 joule per gram degree Celsius. Yun yung specific heat. Silver, 0.24 joule per gram degree Celsius. And for aluminum, we have 0.9 joule per gram degree Celsius. Now, the problem states this way. A 50-gram sample of an unknown metal is heated with 300 joules. If the temperature of the metal increases by 41.6 degrees Celsius, what is the identity of the metal? Now, si metal, it was heated to 800 grams. So, nag-absorb ba siya ng heat or nag-release? Yung 50-gram sample ba, nag-release ng heat or nag-absorb? Pinainitan mo siya eh. Mr. Istomo.
Nag-absorb po, ma'am.
Eh, nag-absorb siya ng heat. So, heat is positive here. Ha? Heat is positive. Okay. Gagamit tayo ngayon ng Q equals MC delta T. Okay. The formula that we are going to use, always remember this formula also. How do you get the constant volume heat? Gagamit kayo ng MC delta T. Sa calorimeter, yun yung pag constant volume, yun yung heat released or absorbed, which is equivalent to delta U. Pag naman constant pressure, yung Q mo equals MC delta T, that is the heat absorbed or released, and it is equal to delta H. Remember, BAM calorimeter, constant volume, QV is equal to delta U. Constant pressure calorimeter, coffee cup calorimeter, QP, heat at constant pressure, is equal to delta H. Tandaan nyo yon, ha? QV is to delta U, QP is to delta H. Sulat nyo na yung mga yon, bagay na yon. Maglista na kayo ng mga formulas na gagamitin nyo para sa quiz and para sa exam. Remember, your final exams will be including gas laws. Marami ng formulas doon. We have ideal gas, we have combined gas, we have Boyle's law, we have Gay-Lussac, we have Charles law. So, yung mga formulas nyo, ilista nyo na. Okay? Also, thermodynamics 1. Pressure. We have atmospheric pressure, absolute vacuum pressure. Okay? Now, it is necessary to find the specific heat of the unknown sample of mass in order to locate it on the list. So this is done by using the equation that is used to determine the specific heat capacity of an element. Okay? So, ang unknown natin dito, yung specific heat, yung C. So, Q is equal to MC delta T since your heat is positive kasi inabsorb niya yung heat, positive, equals 50 grams of the unknown material times the specific heat, this is our unknown, times 41.6. Pag ganito yung statement, pag sinabing increase by, that is already delta T, or decrease by, that is already delta T. If there are no two temperatures given, and isang temperature lang yung binigay sa inyo, that means that, and it is stated increase by, yun na yung delta T. Unless, isang temperature ang given, and you are required to find the initial temperature or final temperature. You get what I mean? Halimbawa, you are required to find the final temperature, or you are required to find the initial temperature. Of course, isang temperature lang ang ibibigay sa inyo na given. But, the specific heat will be given and the mass of the sample will be given also. Always remember the formula, the equation. Q is equal to MC delta T. Okay? So, after which, we were able to derive the specific heat to be 0.385 joule per gram degree Celsius. Okay? So, i-compare natin itong nakuha nating sagot doon sa list, 0.385. So, the metal is copper. The metal is copper. Okay? Now, another problem. Take note of these conversion factors. 1 calorie is equal to 4.18605 joule. Or we can consider 4.184 joule dito kasi yun yung ginagamit natin usually eh. So 1 BTU is 251.996 calorie, 1 BTU is 778.26 Pascal. Actually, these conversion factors are used in your future thermodynamics subject. Gagamitin nyo lahat ito class sa thermodynamics nyo next semester or the following years. The following semesters, higher years ninyo. Okay? So, sa atin, gagamitin na lang natin yung 4.184. Okay? 4.184 gamit natin na. Sulat nyo na sa notes nyo. 1 calorie is equal to 4.184. Kasi yun na yung nagamit natin eh. Last time, palagi 4.184. Tapos sa previous examples natin, saan ba yun? Wait lang, hanapin ko ha. Ayun. Dito 4.184 joule per gram degree Celsius. Actually, this is 4.184 joule in 1 calorie. So, fix natin sa 4.184 para hindi kayo maguluhan. But it's just a very little difference actually, just a matter of 0.002. Okay lang. So, let's proceed to these problems. Actually, class, meron na akong solution dito. We have solved this already in my previous sections. Para mabilis, ipipresent ko na lang sa inyo yung solution. I-explain ko na lang kung paano. Ha? Mahirap kasi mag-type ulit. Yes, Mr. Doringo.
Ma'am, yung sa conversion po, pag na-convert na po ba, ano ba yun? I-round up pa po ba o hindi na po need yun?
3 decimal places lang tayo.
Okay po, ma'am.
4.184 lang, ha?
Okay.
Pero ang mga sagot nyo sa exam, usually up to 2 decimal places. Pero, pag ang hinahanap ay specific heat, up to 3, ha? Up to 3 ang sagot nyo. Tignan nyo sa choices, kung alin yung pinakamalapit na sagot nyo, yun ang i-compare nyo doon sa choices. Okay?
Noted po, ma'am. Salamat po.
Ikita nyo naman sa choices kung alin ang pinakamalapit sa sagot nyo. Now, kung wala doon sa mga choices ang sagot nyo, that means mali ang solution nyo. Okay? Mali. So, if 80 grams of iron shot, ang iron shot is something like a little pieces of iron, parang pellets. Pag sinabing shot, that is pellet also. If 80 grams of iron shot at 100 degrees Celsius is dropped into a 200 grams of water at 20 degrees Celsius contained in an iron vessel, ang calorimeter mo dito is made of iron. Find the resulting temperature. Find the resulting temperature. So another problem, a tank of 10 cubic feet capacity is half filled with glycerin. Glycerin is an alcohol. Alcohol siya. It is a viscous alcohol, malapot na alcohol. So the weight density of glycerin is given, that is 78.6 pounds per cubic foot, but the specific heat is 0.57 BTU per pound degree Fahrenheit. Ano ito? Yung BTU is British Thermal Unit. This is a unit of heat under the English system. Kaya gumamit tayo dito ng Fahrenheit kasi naka-English system yung unit ng heat natin. How much heat is needed to raise the temperature of glycerin from 40 to 70 degrees Fahrenheit? And if heat is supplied to glycerin at the rate of 750 BTU per minute, what rate does its temperature rise? We will be having more of this also in your applied physics soon, or applied physics siguro nyo mamimit itong more of calorimetry. Okay, so let's go to the solution step by step. Wait lang. Stop ko muna to. So, 20 slides pa. Bago tayo matapos. So, bibilisan natin, ha? calorimetric problems. Okay, ito na yung solution ha. My plan is to retype it para mas maintindihan nyo, pero aabutin tayo ng siyam-siyam. So, I decided to present it this way na lang. Alright. Can you see it?
Yes po, ma'am.
Ngayon, ganito yon. Diba iron shot? The mass is 80 grams. Ang temperature niya is 100 degrees Celsius. Ngayon, i-drain up ito sa calorimeter containing water. Yung calorimeter mo is iron. So, ibig sabihin, yung iron na vessel, mag-absorb din ng heat coming from the iron. Diba? Kasi, tingnan nyo, napakainit niya, 100 degrees Celsius. Ngayon, pag drain up yun sa water, mag-absorb ng heat si water, at the same time, mag-absorb din ng heat si calorimeter. Si iron eh. Now, initially, mayroong tubig sa loob, which has a temperature of 20 degrees Celsius. Yun din ang temperature ng iron. Equal doon sa temperature ng tubig. Kaya, nilagay ko dito, initial is 20 for the water, initial din ng vessel, which is iron, 20 degrees Celsius then. Now, the mass of the iron is 80 grams, the mass of the water is 200, the mass of the iron vessel is 50 grams. So, given din yung specific heat ng water, nakakalorie tayo ngayon ha. Calorie is also a unit of heat in the metric system. The same true with joules. Joules and calories. Ang English is BTU. So, for water, the specific heat of water is 1 calorie per gram degree Celsius. For iron, it is 0.12 calorie per gram degree Celsius. Now, we are asked to find the temperature, final temperature. Pag inilagay mo na yung iron shot doon, equal na lahat yung temperature nila. Temperature of the iron shot, temperature of the vessel, and temperature of the water, pare-parehas na yon. Okay? So, ang equation natin is the heat loss by the iron shot is equal to the heat gain by the water plus the heat gain by the vessel. So, it depends kasi kung ano yung mass ng ng water tsaka yung vessel. So, we will be considering now QMC delta T of the iron shot is equal to the QMC delta T of the water plus MQ delta T, MC delta T of the vessel. So, ito na siya. We will be forming this equation M of the water, which is 80 grams, times C of the water, 0.12, times the change in temperature, 100 minus T delta F. T delta F. Okay, ito yung pagiging final temperature ng iron shot. Now, equals to mass of the water times the specific heat times the change in temperature, TF minus 20, plus that of the vessel, which is having a mass of 50 grams, times the specific heat, 0.12, times the change in temperature, that is TF minus 20. Now, solving the equation, simplifying, we get the final temperature to be 23.56 degrees Celsius. Tumaas lang ng konti ang temperature. Nag-change. Naging 3.56 ang increment ng temperature ng water at saka yung vessel. Si iron shot naman, bumaba ng temperature niya, naging 23.56 na lang from 100. Don't worry class, I won't be giving this type of problem sa exam kasi it will take you a long time to do it. Kulang ang oras. So ang gagawin, what we finally made or what we finally decided is to give you na lang two variables, no? Heat loss equals heat gain. Heat loss by the calorimeter equals heat gain by the reaction and vice versa. So, mas madali nang isolve yun. Okay? Naintindihan nyo naman to. Ngayon, kung tatanggalin ko yung vessel, ganun na lang ang magiging, ano nyo, i-consider nyo. Ano yun, Mr. Dupa?
Ma'am, hindi na i-convert sa Kelvin yung temperature.
Hindi. Kasi
Okay.
given ito as per gram Celsius, magka-cancel out na yung mga temperature. Now, you will consider Kelvin sa gas loss. You will consider Kelvin sa sa entropy. Entropy, tandaan nyo, sa entropy sa thermodynamics part 3. Okay? Sana matapos natin yung part 3 ngayon para makapag-quiz na tayo sa Thursday. Okay, no questions here? Let's move to the next problem. O, screenshot nyo muna. Okay na? Okay na siya?
Ma'am, pati din po ma'am yung yung question. Pwede po.
O, nandun sa PPT yun.
Ay, okay po ma'am. Okay na
Sa
po ma'am.
Open nyo na lang yung PPT nyo sa BS, ha? Okay. So, let's move to the solution of the next problem. Ito naman, mas simple na ito. Okay? Di ba the volume of the tank is 10 cubic feet? Nandun siya sa loob ng tangke. Tapos, it is half-filled with glycerin. So, if it is half-filled with glycerin, ibig sabihin, 5 cubic feet ang volume ng glycerin doon sa loob ng tangke. Okay. The density is 78.6 pounds per cubic foot. Given din yung specific heat ng glycerin, which is 0.57 BTU per pound degree Fahrenheit. The initial temperature is 40 and the final temperature is 70. So, ibig sabihin, glycerin was heated up. Pinainitan si glycerin. Now, how are you going to get the mass? Kasi ang gagamitin natin dito is Q is equal to MC delta T din. Gamitin ko na lang dito small q para hindi kayo maguluhan. Although, kahit small q or capital letter Q ang gamitin nyo, pareho lang. Basta pag Q, uppercase or lowercase, it denotes heat. Okay? Absorb or release. Okay. So, meaning to say, initially 40 degrees Fahrenheit. Pinainitan mo siya, so naging 70 degrees Fahrenheit ang temperature. Now, determine the mass by making use of density is equal to mass over volume. Palaging ginagamit yan. Mass density is equal to mass over volume. Number of mole is equal to mass over molar mass. Tandaan nyo yan palagi. Ha? Now, by making use of density is equal to mass over volume. Mass is equal to density times volume. Diba? So, makukuha natin, the mass is 393 pound mass. In terms of pound mass tayo. Kasi nasa English system. So, after which, we will be getting the heat is equal to MC delta T, 393, the mass, times the specific heat, 0.57, times the change in temperature, final minus initial, 70 minus 40. We get 6,720.3 BTU of heat was absorbed by glycerin. Okay? Now, how much is the heat added? How much is the increase in temperature per unit time if you are adding 750 BTU per minute? So, ano naman yung increase in temperature, no? Degree Fahrenheit per minute naman ang isusolve natin. Parang yung ice nga pag natunaw, di ba? Every unit per unit time, nag-i-increase yung temperature yung ice habang nagmi-melt siya. Okay, so degree Fahrenheit per minute ang unit natin. So where are we going to get the Fahrenheit as a unit of temperature? Kukunin natin doon sa specific heat. Okay? Specific heat. So dapat nasa taas yung pound degree Fahrenheit. So, 1 pound degree Fahrenheit is 2.57 BTU, diba? Now, in order to eliminate BTU, of course, dimensional analysis na yung ginagamit natin dito, i-multiply natin doon sa heat per minute. That is 750 BTU per minute. Okay, cancel out na yung BTU. So, the next thing to do is to cancel out pounds. Anong gagamitin natin? Yung mass. 393 pounds. Nasa ilalim siya para mag-cancel out sa pounds. And calculating, we have 3.35 degree Fahrenheit per minute. Meaning to say, tumataas ng 3.35 degree Fahrenheit sa bawat minuto na nag-a-add ka ng 750 BTU. Okay? Naintindihan nyo yung solution. Okay, take a screenshot. Question dito, naintindihan? So ano yung mga simple formulas na ginamit natin dito? Density is equal to mass over volume. Diba? Q is equal to MC delta T. Remember that when you see a problem in which a specific heat capacity is given, always remember the formula Q is equal to MC delta T. Okay? Last, always remember the formula Q is equal to MC delta T. Okay? Na-screenshot nyo na. Ha?
Yes po, ma'am. Doon na po.
Okay, next problem. May isa pa. Ito naman, lead pellet. Yes, Mr. Borbor.
Ma'am, ask ko lang po kung ano po, kung kailan po ulit mag-convert ng Celsius to Kelvin po.
Sa gas loss.
Gastos lang
Gas
po, ma'am.
loss. Oo. Tapos kasi ito, ang given kasi class is depende sa given na na specific heat. Dito nyo i-base. Kasi ang specific heat naka Fahrenheit at saka Celsius lang ibibigay namin sa inyo para hindi kayo malito. Ha? Okay? Tapos, doon din sa part 3 ng thermodynamics. The temperature that is used in entropy is Kelvin. Okay? So, doon lang kayo gagamit ulit ng Kelvin sa part 3. Nasa part 2 tayo. Sa part 2 kasi, we dealt with specific heat, capacity, enthalpy, what else? Heat, constant volume, delta HB, QV, QP, delta H, and delta U. Sa part 3, gagamit tayo ng another thermodynamic property, which is entropy. Ang unit kasi ng entropy is Joule per Kelvin. Joule per Kelvin talaga. Okay? Next problem. Ito. Lead pellet naman. This is a lot simpler than the first two problems. Ang problem lang dito is ang unknown is specific heat. Hahanapin nyo naman yung specific heat. Pero, you will be using the same formula. Q is equal to MC delta T. Very useful yung formula na MC delta T for Q. Okay, a lead pellet having a mass of 26.47 grams at 89.98 degrees Celsius was placed in a constant pressure calorimeter. Take note, negligible heat capacity. So, hindi natin isasama dito yung calorimeter. Kanina sa iron shot sinama natin kasi nag-absorb ng heat si iron. Kasi it has a specific heat capacity. Metal kasi siya. Maybe ang calorimeter dito is hindi siya metal. Kaya negligible yung heat capacity. Do you get what I mean? Pag negligible yung heat capacity niya, hindi siya nag-absorb ng heat. Hindi rin nagre-release ng heat. Okay? So, we will just be making use of the lead pellet and the water. Yung water nandun sa loob ng calorimeter. Okay? So, constant pressure, negligible heat capacity, the calorimeter contains 100 milliliters of water. Now, the water temperature rose from 22.5 to 23.17. So, umakyat yung temperature ng water kasi nga, because of the presence of lead. Mainit siya, 89.98. Now, you are asked what is the specific heat of lead pellet. Okay. So, ibig sabihin, nag-release ng heat si lead. Diba? So, negative heat. Nag-release, negative heat. Tapos, inabsorb ni water, positive heat. Naintindihan nyo? Walang pakialam ngayon si calorimeter. We are only concerned with the lead pellet and yung water. You got it? Kasi nga negligible yung heat capacity ng calorimeter. You got it, class? Naintindihan niyo? The problem naman will state it kung negligible. Kung kasama yung calorimeter, ilalagay naman namin yung specific heat ng calorimeter. Okay? Do you understand?
Okay po.
Iisa lang ang sumasagot sa akin. So, ang specific heat ng water is 4.184 joule per gram degree Celsius. So, masosolve na natin yung heat absorbed by the water. Diba? MC delta T. So, substitute mass times specific heat times change in temperature. We got positive 280.3 joule. Inabsorb kaya positive. Inabsorb ni water. Now, for the specific heat of lead pellet, okay, diba equal sila, mag-change lang tayo ng sign. So, the heat released by lead is negative kasi ni-release niya, diba? Negative 280.3. So, isa-substitute nyo ngayon, negative dito si heat released by the lead pellet. So, negative 280.3 okay, is equal to 26.47, the mass of lead, times yung unknown natin, specific heat ng lead, times the change in temperature, final minus initial, 23.17 minus 89.98. So we get the specific heat of lead to be 0.158 joule per gram degree Celsius. Okay, ayan. Okay? Naintindihan? Wala itong problem na ito sa sa PowerPoint natin. Okay. Ngayon, if you will be given a problem like this, the heat absorbed, gagamitin ko to the heat absorbed or the heat released by lead is 280.3. Find the specific heat of lead. Ito lang ang magko-concentrate lang kayo sa formula na to. Okay? Determine the specific heat of lead if it absorbs or if it releases 280.3 joule of heat and the temperature changes from 89.98 to 23.17. Ayun. Ito na kagamitin nyo. Makukuha nyo na yung specific heat. Okay? Got it? Basta pag na-meet nyo tong problem na ganito, given yung change in temperature, tapos yung heat given, you are required for the specific heat, Q equals MC delta T kaagad ang iisipin ninyo. Understood? Question class. Naintindihan nyo? Sagot.
Ma'am, medyo confused pa po, ma'am.
Alin diyan? Saan kayo na-confuse?
Sa po, ma'am?
Saan?
Yan po sa question po yan, ma'am. Pwede po, ma'am, pwede po, ma'am, paulit ng mabilisan lang po ulit.
Saan?
Lahat po.
Lahat. Di ba given ang specific heat ng water? Ang hahanapin mo yung specific heat ng lead. And kasi pareho sila ng heat eh. Nag-release si lead, kinuha naman ni water. Meaning pareho ng value ng heat. Mag-change ka lang ng sign. Inabsorb ni water yung heat, kaya positive ang heat niya. Na-solve ang heat by making use of MC delta T, which is the formula for heat. Heat absorbed or heat released, making use of specific heat. O nakuha mo na, positive siya kasi absorb. Ngayon, ni-release ni lead yung heat na yon, kaya negative siya. Ito since heat released by lead is negative, yun ang gagamitin natin naman dito sa formula. Pero negative si heat dito. Then, MC delta T. Yung C dito, yun yung hahanapin mong specific heat ng lead. Yung temperature niya kasi initially is 89. So, ito yung initial temperature mo. Baka gamitin mo is 22.5. Hindi, that is for water. And the final temperature kasi is 23 for both the lead and the water noong inilagay mo na siya sa calorimeter. So by that, you will be able to compute for the specific heat of lead by simplifying this equation. Okay, nakuha.
Opo, ma'am. Thank you po.
Naintindihan. Okay, para ma-simplify ito, i-subtract nyo muna ito. Huwag nyong idire-diretso kasi may mga calculator na may nagkaklase Mr. Villapando inuutusan. Okay. So by this, simplify, i-subtract nyo muna to bago nyo i-divide doon sa 280 para mas madali. Huwag nyong idire-diretso sa calculator ha. Pag halimbawa, 26.47 times 23.17 minus 89.98, mali ang lalabas sa calculator nyo. Simplify nyo muna to, subtract nyo muna. Okay? O, screenshot nyo na.
Okay na po, ma'am.
Okay, let's continue. Bakit kayo nadidisi? Sana hindi kayo nadidisi. Okay, let's continue. Okay, another. We have to consider Hess law. Okay, if a reaction is carried out in a series of steps, delta H for the overall reaction will be equal to the sum of the enthalpy changes for the individual steps. The key terms here are enthalpy, state function, Hess law, enthalpy of formation, standard enthalpy change, and standard enthalpy of formation. Okay, anong ibig sabihin ng Hess law? Because delta H is a state function. When we say state function, those thermodynamic functions or thermodynamic variables that can be considered to have initial and final condition. Yun yung may mga changes, like change in enthalpy, change in internal energy, change in volume, change in temperature. Those are state functions. Okay? So the total enthalpy change depends on the initial state of the reactants and the final state of the reactants. So during reaction, chemical reaction, the in-between does not matter because the steps are additive. Okay? Even in between may nangyayari, you can actually add them up. So anong ibig sabihin noon? Okay, ganito yon. For the reaction of methane plus oxygen, 1 mole of methane plus 2 moles of oxygen gas to give you 1 mole of carbon dioxide and 2 moles of water. May nangyayari sa gitna. Now, the delta H of the reaction actually is negative 890 kilojoule. Ang ibig sabihin nito is the reaction spent or the reaction nag-release ng 890 kilojoules of heat, no? Wait lang, class, may tawag. Okay. And now, like for instance, of course, when you say CH4 plus 2O2, this is combustion, di ba? Pag combustion, magre-release ng heat yung reaction. So, combustion of methane gas, it needs oxygen. But in between, there shall be carbon monoxide plus 2 moles of water plus 1 mole of oxygen, which will also produce carbon dioxide plus 2 moles of water. Now, yung delta H dito, in between, are additive. There are two changes in enthalpy of the reaction here. We have 607 and 283 kilojoule. Pag inad mo to, you will produce negative 890 kilojoule also of enthalpy. So, yun ibig sabihin ng Hess law. Ngayon, para maintindihan nyo mas maigi, we have this example. Now, for the reaction of carbon and oxygen to produce carbon dioxide, publications tell us that this can occur as two steps. Two steps siya. First, carbon will react with 1/2 mole of carbon monoxide. Mayroon ng delta H na na-release dito. Mayroon ng heat na na-release, equivalent to negative 110.5 kilojoule. Now, when carbon dioxide reacts with 1/2 mole of oxygen ulit, to produce carbon dioxide, there is another change in enthalpy of the reaction, which is negative to 83.0 kilojoule. Now, pag inad mo tong dalawa, it will sum up into negative 393.5 kilojoule. Now, when we add also the reactions, products and reactants, okay, 1/2 oxygen plus 1/2 of oxygen will give you 1 mole of oxygen. Ibababa natin si carbon and carbon monoxide. The same is true for the products, CO plus CO2. Now, take note that carbon monoxide sa reactant and carbon monoxide sa product will cancel out. So our net reaction actually is carbon plus oxygen will give you carbon dioxide. Inad mo rin yung delta H nila, negative 393. Kaya nga additive. Okay? Hess law allows us to add equations. We add all reactants, products, and delta H values. Okay? So this can be illustrated by the following example. But before that, we have what you call, of course, paano magkakaroon ng reaction? We have what you call the delta H of formation, the change in enthalpy of formation of the compounds present in the reaction. So, enthalpy change for the reaction in which a compound is made from its constituent elements in their elemental forms. So, subscript F indicates substance that has been formed. Okay? So, here, the magnitude of enthalpy of the compounds actually are dependent on temperature, pressure, state of the compound, if it is a gas, a liquid, or solid. That is the state of the reactants and products. Now, in order to compare enthalpies, a set of conditions for tabulation must be defined. That is the standard state. Yung standard state, yun if they are gas, solids, or liquid. Okay, so we have here what we call the standard state, standard enthalpies of formation at their standard state. So delta HF are measured under standard conditions at 25 degrees Celsius and 1 atmosphere. Etong mga values na ito, class, were taken at standard conditions at 1 atmosphere pero room temperature 25 degrees Celsius or 298 Kelvin. Ang unit niya, di ba sabi ko sa inyo, change in enthalpy is a molar thermodynamic property, meaning per mole. Tignan nyo yung units nila, oh. Kilojoule per mole. Okay? And they have corresponding values, negative and positive. Depende sa the amount of heat that is released or absorbed during reaction. So notice, class, na we only have delta H of formation of compounds. Walang delta H of formation of elements. Okay? Compounds lang ang meron. Gagamitin natin ito mamaya sa pag-solve ng problem. Okay. Now, enthalpy change when all reactants and products are in their standard states. So, we denote it by delta H. May degree dito, ibig sabihin, standard state siya. Okay? Kung ano yung standard state nila, kung naging gas sila or liquid or solid. Now, the change in enthalpy for the reaction that forms 1 mole of the compound from its elements with all substances in their standard state. They are usually reported at 298 Kelvin or 25 degrees Celsius. So, it is denoted by delta HF, standard state. Now, standard enthalpy of formation of the most stable form of any element is 0 because there is no formation of reaction needed when element is in its standard state. Diba? Wala namang formation ng oxygen gas, diba? Kasi diatomic siya, O2. Yung mga solid din. Pero, of course, basta i-consider nyo na ang delta H of formation is for compounds only. Sa Hess law, sa Hess law. Okay, so example natin. Okay, propane gas, when reacted with 5 moles of oxygen, will give you 3 moles of carbon dioxide and 4 moles of water. This is actually a combustion reaction. So, we can imagine this as occurring in 3 steps. Propane will decompose into 3 moles of carbon and 4 moles of hydrogen gas. Now, carbon also can react with oxygen to form carbon dioxide. Si hydrogen naman will react with oxygen to form water. So, tignan natin. Isa-sum up natin tong reaction na to. Okay? So, when we add all the reactants and the products, makikita nyo na magka-cancel out dito si carbon sa reactant and sa product. Now, hydrogen also will cancel out sa product and sa reactant. But we are going to add up 3 oxygen plus 2 oxygen to give 5 oxygen. Now, add up also 3 carbon dioxide plus 4 water. So, ito na yung net reaction natin. So, ito yung i-consider natin sa pagsusolve ng delta H of the reaction. Okay? So, ito na siya. Another formula to be considered according to Hess law is delta H of the reaction is equal to delta H of formation of the products times the number of moles. Yung number of moles dito, yun yung mga coefficients. Minus the summation of the delta H of the reactants, delta HF of the reactants times the number of moles of the reactants. Okay, so products minus reactants. Now, sa product natin, carbon dioxide, there are 3 moles. So, hanapin natin si carbon dioxide. Ayun. Oops. Saan na yun? Ayan. Carbon dioxide actually has a delta H of formation of negative 393.5. Ano pa yung isang product? Water, di ba? Water has a negative 285.8 kilojoule per mole as the delta H of formation. Ano yung reactant natin? Propane, di ba? Propane. C3H8, negative 103.85 kilojoule per mole. What is the other reactant? Oxygen. 0 for oxygen kasi nga element lang siya. There is no delta H of formation. Okay? So, let's go back to the calculation. Actually, addition, subtraction lang ito class of sign numbers para makuha nyo yung delta H ng reaction. So, by adding up, summing up, this is for the products, carbon dioxide and water, and this is minus the reactants, 103 kasi 1 mole lang times negative 103.85, the delta H of formation of propane, plus 0. 5 times 0 for oxygen, di ba? Kasi 0 nga. And then, just add it up, you will be getting the delta H of the reaction, which is negative 2219.9 kilojoule. This is according to Hess law. Okay? Naintindihan? Naintindihan? This is for chemical reaction regarding Hess law. Did you understand, class? Yes, Mr. Borbor.
Ma'am, yung parang table po na pinakita nyo, dun po kami magbe-base.
Yeah.
Okay po. Thank you po.
Okay? Bibigay naman sa inyo just in case na bigyan kayo ng ganitong problem. But maybe I think we decided not to give you this type of problem anymore. So let's see kung mag-a-appear sa exam. Kasi masyadong ano eh. But anyway, pag pagbibigyan kayo ng ganitong problem, ibibigay na sa inyo yung delta H of formation. Especially pag nasa part 3 na tayo. Okay? Now, the last part of thermodynamics part 2 is about heat engine. Wala nang calculations dito. Just remember what heat engine is. So, when you see heat engine, it is the device which converts chemical energy of fuel into heat energy, and this heat energy is utilized, converting it to mechanical energy. So, a heat engine is a system that performs the conversion of heat to mechanical energy, which can then be used to do mechanical work. Parang yung diniscuss natin sa part 1, yung internal combustion engine na mayroong piston and cylinder assembly. Diba? Now, this is actually a schematic diagram of an elementary heat engine wherein a source which has a temperature, andiyan kababa, Mr. Coronel, will release heat absorbed by the working substance, and this heat will be converted into energy in the form of work. All right? So temperature 1, we have initial temperature and final temperature. Okay? Now, classification of heat engines, we have external combustion engines. Yung mga malalaking engineering devices like what you call a reactor, no? So these are considered yung mga train. These are considered to be making use of EC engines. External. So what is an EC engine or external combustion engine? It is a heat engine where a working fluid is contained internally, is heated by combustion in an external source through the engine wall or a heat exchanger. The fluid then, by expanding and acting on the mechanism of the engine, produces motion and usable work. All right? So, for example, an external combustion engine would use a flame to heat water into steam, then using the steam to turn a turbine. A boiling water reactor, which is an external heat engine. All external combustion engines are considered to be EC engines, external heat engines. Okay? So ito naman yung internal combustion engine for smaller vehicles like cars. Okay? So we have the piston and cylinder assembly wherein the fuel is injected inside in the presence of air, of course, and heat. There will be combustion. The gases that are produced here will be down in the piston and cylinder assembly are the ones that will render to do mechanical work. So, internal combustion is an engine that generates motive power by the burning of gasoline, oil, or other fuel with air inside the engine. The hot gas is produced being used to drive a piston or do other work as they expand. The gases will expand, okay? Parang nagmo-move ng ganito yung piston sa loob ng cylinder. Okay, the heat engine cycles that are applied, of course, are what we call the Carnot, the Rankine, the Otto, and the diesel cycle. In your higher thermodynamic subjects sa third year or second year, you will be dealing with the different cycles. Ito yung 4 na cycles in which you are going to apply the different processes like isothermal, adiabatic, isobaric, okay, type of processes dito sa heat engines na to. We will not be discussing this anymore because you will be dealing this particular cycles in your higher thermodynamics 1 and 2 later on in your higher years, okay? I just want you to know that you will be meeting this up in your higher thermodynamic subjects. Okay? Any question that ends thermodynamics part 2? Okay? If there are no questions, I will be presenting to you thermodynamics part 3. Break tayo 12 o'clock, ha? Nandiyan pa ba kayo?
Yes po, ma'am.
Yes, ma'am.
Yes po, ma'am.
Iniwanan nyo na ako eh. Okay, we will be having another thermodynamic property in terms of entropy and Gibbs free energy. Dapat tapusin natin ito kasi mag-quiz tayo sa sa Thursday next week. 40 slides lang naman to. Okay, so for part 3, we will be dealing with second law of thermodynamics. Actually, there are many statements regarding the second law. Again, what is the first law of thermodynamics? What is the first law of thermodynamics, class? What is the first law? Hala. What is the first law of thermodynamics? Yes, Mr. Estomo?
Ano po, energy can neither be created nor destroyed.
Okay, energy can neither be created nor destroyed, only transformed. Diba? Now, first, the second law, maraming statement ito. It can be completely converted into work in a single process. But continuous conversion of heat into work requires a cyclic process. Yung heat engine, no? All attempts to construct a heat engine that is 100% efficient have failed. Walang 100%. Now, the Kelvin-Planck statement of the second law of thermodynamics is a qualitative statement of the impossibility of certain types of processes. That is 1. Wala pa dyan yung thermodynamic property na sinasabi ko. Now, the law states that it is impossible for an engine working in a cycle to transform a given amount of heat from a reservoir completely into work. So, not all the thermal energy in the thermal system is available to do work. Okay. Now, the second law of thermodynamics is a statement about which processes occur and which do not. There are many ways to state the second law. Here is 1. Heat can flow spontaneously from a hot object to a cold object. Spontaneous meaning forward reaction, no? It will not flow spontaneously from a cold object to a hot object. It will not flow spontaneously from a cold object to a hot object. So it is non-spontaneous. Now, according to Clausius' statement, no device, statement naman ito ni Clausius, no device has been observed for which work is equal to 0. This leads to a second way to state the second law of thermodynamics. It is impossible to make a cyclic engine whose only effect is to transfer thermal energy from a colder body to a hotter body. Okay? So that is another statement. Now, this statement of the second law is what I'm telling you about, an introduction of another thermodynamic property, which is entropy. Okay? Entropy. Sa part 2, diniscuss natin yung enthalpy, di ba? And sa part 1, more of delta U. Sa part 2, more of delta H. And heat, of course. So what is entropy? So entropy and the second law of thermodynamics. Recall that in thermodynamics, a system in an equilibrium state is characterized by its state variables. So ano yung mga state variables natin? Pressure, volume, temperature, internal energy, and number of moles. These are the state variables. Now, the change in state variable for a complete cycle is 0. Take note, the change in a state variable for a complete cycle is 0. Let's say we have a Carnot engine cycle, no? The change in state, pag nakumpleto mo yung cycle, is 0. But in contrast, the net thermal energy and the net work factors for a cycle are not equal to 0. There is always a net thermal energy in a cycle. Okay? So, a little bit of history. In the latter half of the 19th century, Rudolf Clausius proposed a general statement of the second law in terms of the quantity called entropy. So, according to Clausius, the inclusion of entropy is necessary for the second law of thermodynamics. So, what is entropy? Entropy is a thermodynamic function of the state of the system. It can be interpreted as the amount of order or disorder of a system. So as with, pag sinabing order or disorder of the system, yun yung value that will be related to how a reaction is going forward or backward. It depends upon the temperature also. So as with the internal energy, it is the change in entropy which is important and not its absolute value. So we will be incorporating delta S. Di ba, meron tayong delta H, delta U. So now we have delta S. Okay, but before that, let's take a break first. Kain muna tayo for 10 to 15 minutes and then let's get back for the continuation of our lesson.
Okay
Okay?
po, ma'am.
Sige. See you later. Kahit anong halo mo pa doon sa kape mo, hindi na pwedeng bumalik as sugar and milk. Diba? Because it can't be undone anymore. Yun yung entropy. In a process, if it is done already, you can undone it anymore. So kaya nga sabi, it is a measure of the disorder of the system. But it depends upon the temperature. Because when you say entropy, you are dealing with heat again. But that added heat is actually depending on temperature. Hindi siya i-multiply mo sa temperature, but it depends the temperature So heat over temperature ang ano niya. When you say change in entropy. Another situation. When a tornado hits a building, there is major damage. Tama ba? You never see a tornado approach a pile of rubble and leave behind a building behind when it passes. Pag dinaanan na siya ng tornado, of course, hindi na nakatayo yung building. Pag may mga pile of rubble already. This is similar with thermal equilibrium. Alright? The uniform final state has more disorder than the separate temperatures in the initial state. Parang it's like you are going to measure the heat, of course, which is based on temperature. Based on temperature. So, halimbawa, natunaw yung ice, no? There is change of temperature already. Unless you are going to do another process in which it will turn back into ice again. Diba? So, we consider now the change in entropy. The change in entropy, delta S of a system when an amount of thermal energy, Q, is added to a system by a reversible process at constant absolute temperature is given by delta S is equal to Q over T. O, dagdag nyo na ito sa formula nyo. Delta S, the change in entropy is now equal to the heat over temperature. Now, the temperature here is always in Kelvin. So the units of the change in entropy are joule per Kelvin. K negative 1 means per Kelvin, meaning nasa denominator siya. Joule per Kelvin. Okay? Ay, naku, Mr. Katunina, you're too late. Hindi mo na naabutan yung mga discussion namin. Mr. Katunina.
Po, ma'am. Dalawang device lang po ginagamit ko po.
You were late, so you were not able to catch up with the first lesson that we took up.
Hindi po
Okay,
yung laptop ko, ma'am.
now the units of change in entropy again is delta S is equal to Q over T. Okay, another statement of the second law of thermodynamics. The total entropy of an isolated system never decreases. What again is an isolated system? Can you still remember? We have open, we have closed, we have open system, closed system, and isolated system. Ano na yung isolated system? Huh? Can you still remember? Hello? Review pag may time, ha? Yes, Mr. Montealegre.
Cannot exchange energy po, ma'am.
And? Energy lang ba?
And matter po.
Okay, so no exchange of energy or mass. Okay, no heat energy, no release of energy or heat energy to the surroundings. So that is isolated. So when you say the total entropy, of course, of an isolated system never decreases kasi nga isolated yung system. So another statement of the second law. So, okay, naulit. So we have here an example. Ano yung problem? Okay, a heat engine removes 100 joules each cycle from a heat reservoir at 400 Kelvin and exhausts 85 joule of thermal energy to a reservoir at 300 Kelvin. Compute the change in entropy for each reservoir. Okay, let's take the first reservoir. What happened to the reservoir? Meaning, the heat engine removes 100 joules from a heat reservoir. So what happened? The first reservoir absorbed heat or released heat? Released. So therefore, we can say that it is negative. Now, part of the heat that was released by the first reservoir was injected to a second reservoir. The amount of heat injected to it is 85 joules. So did the second reservoir absorb or release heat?
Absorb po, ma'am.
Absorb. So positive. Now compute the change in entropy for each reservoir. Okay. Since the hot reservoir loses heat, we have delta S Q over T is equal to negative 100 joules per 400 Kelvin. So we have a negative 0.25 joule per Kelvin. Now for the cold reservoir, we have, since it absorbed heat energy, 85 joule over 300 Kelvin. So we have 0.283 joule per Kelvin. Therefore, we can say that the increase in entropy of the cold reservoir is greater than the decrease for the hot reservoir. Kasi tingnan nyo yung value niya, 0.283. Samantalang if you compare it to the absolute, 0.25 lang. Okay? So that is the increase. So it depends upon the temperature or the change in entropy. Okay? So as simple as that. Now, for natural systems, in this example and all other cases, it has been found that the total entropy increases. This infers the total entropy increases in all natural systems. And we can also say that the entropy of a given system can also increase or decrease. But the change in entropy of the system, delta S, plus the change in entropy of the environment, delta S of the environment, must be greater than or equal to 0. So we will have this as an equation. Delta S, okay, is equal to delta S of the system plus delta S of the environment. So this is the total delta S, should be equal or less than 0. Should be equal or less than 0. Okay? That means to say delta S of the system plus delta S of the environment should be equal or greater than 0. So the second law of thermodynamics now in terms of entropy can be stated as the total entropy of any system plus that of its environment increases as a result of all natural processes. The entropy of the universe also increases, and natural processes tend to move toward a state of greater disorder. So what determines the disorderliness of a reaction, of a thermodynamic process? It's the entropy, the change in entropy. Okay? The change in entropy determines the disorderliness of a thermodynamic process. Okay? Sa ano nyo, sa cycles ninyo later on, gagamitin nyo na si entropy doon sa mga cycles ninyo. Sa thermodynamics nyo later. Okay? Sa higher year. Now, let us relate now entropy and Gibbs free energy. So another thermodynamic property now is Gibbs free energy. So Gibbs free energy is the energy associated with a Gibbs with a chemical reaction that can do useful work. It is equal to the enthalpy minus the product of the temperature and entropy of the system. So, i-relate natin ngayon si Gibbs free energy sa entropy and enthalpy. So, the formula now is G, which is Gibbs free energy, equals H, enthalpy, minus the temperature multiplied by entropy. But at constant temperature, we will be considering now the change in Gibbs free energy, which is equal to change in enthalpy minus the temperature times change in entropy. Okay, dagdag nyo na ulit ito sa formula nyo. Delta G is equal to delta H minus T delta S. Delta H is equal to Q minus P. Delta H is equal to delta U minus T delta S. Delta U is equal to Q plus W. Okay? My advice is for you now to collate the different formulas that you need para maging familiar kayo at alam niyo kung anong gagamitin nyo. Now, the change in Gibbs free energy predicts the direction of a chemical reaction. Take note, the change in Gibbs free energy predicts the direction of a chemical reaction. If delta G is negative, then the reaction is spontaneous. Pag sinabing spontaneous ang reaction, forward ang reaction, nagpo-produce ng product. Okay? And there is excess of energy, kaya nag-move forward yung reaction. Pag negative ang delta G, ibig sabihin pag negative, less than 0. Now, if delta G is positive, it is greater than 0, then the reaction is non-spontaneous, meaning there is not enough energy for the reaction to move forward. So, mag-move backward siya. So, pag delta G is positive, nag-move backward. The reaction is no longer spontaneous. It becomes non-spontaneous. Okay? Now, of course, this is as per William Gibbs. Parang yung Hess law, remember yung Hess law kanina? Meron ding equation which is derived from the theory of Gibbs. Gibbs realized that for a reaction, a certain amount of energy goes to an increase in entropy of a system, and a certain amount goes to a heat exchange for the reaction. So we are referring to delta H and delta S here. So according to Gibbs, Gibbs free energy is a state variable measured in kilojoule per mole, just like delta H. We also have what you call the delta G of the reaction, just like delta H of the reaction in Hess law. And gagamit din tayo ng products minus reactants. That is the Gibbs free energy of formation for the products minus the summation of the Gibbs free energy of formation of the reactants multiplied by the corresponding number of moles. Diba? Kanina, class, sa Hess law. Tapos, mayroon din siyang other equation. We have delta H is equal to, delta U minus P delta V. Diba? Kanina. Next. Now, G is a measure of driving force. So, ito yung formula, tatandaan nyo to ha. R stands for reaction. When delta GR is negative, again, forward reaction has excess energy and will occur spontaneously. Lagay nyo na yung mga situation na ganito. I-note down nyo na. When delta GR is positive, there is not enough energy in the forward direction, and the backward direction will occur. So, we also have another condition, which is delta GR is 0, which is the reaction is at equilibrium. Okay, so take note. Delta G, negative, spontaneous reaction, forward reaction. Delta G, positive, non-spontaneous, backward reaction. Okay? When delta GR is 0, it is at equilibrium. Meaning, it can neither go forward nor backward. So the reaction will be reversible. Nakaganon yung arrow going back and going forward and going backward. Now, with equilibrium condition class, we will be considering the natural log of an equilibrium constant. Pero hindi na natin iti-take up ito. We will be considering the forward and backward reaction lang. Okay, this will be dealt with in higher chemistry subjects like analytical chemistry. So, hindi na natin iti-take up ito. But I'm just going to show you the formula that will be used in which the equilibrium constant is incorporated. Now, ang i-consider lang natin sa delta GR in equilibrium is determining the time, the temperature, I should say, determining the temperature when delta G forward is equal to the G backward. Or kailan, anong temperature dapat yung delta GR becoming non-spontaneous from spontaneous. Mamaya, i-take up natin yon. So these are the equations that I'm talking about na gagamitin ninyo in which you will be using an equilibrium constant. Ito siya. Itong equilibrium constant na ito, you're going to find it out by making use of the concentration of the products and the reactants in terms of molarity or normality. That is mole per liter. So in this type of relationship with regards to reactions, we have now delta GR is equal to 0. So the reaction is at equilibrium. Gagamitin mo tong mga formula nito. So we will be skipping this class, ha. I just introduced you to the formulas. Okay. So entropy and Gibbs free energy. Of course, how are entropy and enthalpy related? So for delta G, we have Gibbs free energy in terms of joule or kilojoule. And then enthalpy, of course, joule and kilojoule din ang unit. Now, di ba si delta S is joule per Kelvin? Tama? So you need the temperature in order for the temperature, unit of the temperature to cancel out para si delta S ay maging joule din or kilojoule. Okay? Gibbs free energy is the energy that is available to do useful work. Now, a reaction will spontaneously occur if delta G is less than 0. At yung sinabi natin kanina. And that is what you call an exergonic reaction. Parang exothermic din. Di ba ang exothermic reaction is that the heat is negative kasi nag-gives off ng heat. Nag-release ng heat kaya negative. Parang similar to delta G. Exergonic, exothermic. Now, a reaction will not spontaneously occur if delta G is greater than 0. You call it endergonic, parang heat din. If heat is greater than 0, it means to say that the heat is absorbed. Okay, kasi positive siya. Exergonic, endergonic. Now, the change in Gibbs free energy, delta G, for any process is related to changes in enthalpy and change in entropy by the relationship, again, delta G is equal to delta H minus T delta S, where T is the absolute temperature in Kelvin. Now, again, when delta G is less than 0, there is a thermodynamic driving force for the reaction or process in the forward direction. Okay, when delta G is positive, then reactants are favored instead. Okay, another relationship. Pag delta G is negative, forward reaction, spontaneous reaction, excess energy, and product favored. Anong ibig sabihin ng product favored? More products are produced, more products than the reactants. More products are produced. Now, pag sinabi namang delta G is positive, reactants are reactants are favored. Delta G positive, reactant favored, meaning mas maraming reactants kaysa products. And non-spontaneous, not enough energy. Okay? Reactant favored, backward reaction. Okay, na-differentiate nyo na. Delta G again, 0. The system is at equilibrium. Okay. Now, this is just to show you how delta G of the system has been derived, or delta G of the reaction has been derived. So, di ba, delta S of the universe is equal to delta S of the surroundings plus delta S of the system. Now, yung delta S of the surrounding is actually negative delta H of the system over temperature. I-equate nyo na ito. Delta S of the surroundings is actually negative delta H of the system over T. So, sinubstitute natin dito yon. Now, multiply it by, simplify the equation by multiplying by negative T. We have negative T delta S of the universe equals delta H of the system minus T delta S of the system. Now, negative T delta S of the universe actually is the change in Gibbs free energy of the system. So we can now equate this also as delta G of the system. So delta G of the system is equal to delta H of the system minus T delta S of the system. Now, the system here that we are referring to is, of course, we can also consider that as the delta G of the reaction. Okay? Sulat nyo na yung mga formulas nyo. Now, to summarize, okay, what this formula tells us, Gibbs free energy change is equal to the total energy change for the system minus the energy lost in disordering the system. So, ito yung energy lost in disordering the system. Okay? This one is the one responsible in the disorder of the system. So, again, take note of the following. Exothermic, negative delta H, meaning to say, given off ang heat. So, energy is dispersed. Entropy increases, positive si delta S. Matter dispersed. Then, delta G must be negative. Therefore, reaction is spontaneous and product favored. Naintindihan nyo? You got it, class? Basta tandaan nyo na lang yung mga conditions. Please, i-note down nyo na yung mga conditions para hindi kayo malito. Now, if delta G is negative, what happens? What did we say if the delta G is negative? Reaction is spontaneous. Therefore, product favored. Okay? So, let's have an example. And one more condition. If the reaction is endothermic, we have a positive delta H. Tama ba? And entropy decreases, negative delta S. Then, delta G must be positive. So, if delta G is positive now, reaction is not spontaneous and is reactant favored. Basta tandaan nyo, pag ang delta G is positive, spontaneous. Pag negative, non-spontaneous. Okay? So, we have these conditions. Okay, ito yung pinaka-summary, class. If delta H is exothermic, that means negative siya. Delta S is positive, increase. So, delta G is reaction favored. Product favored, I should say. Product favored or spontaneous. Pag delta H is endothermic, positive siya. Delta S decreases. Delta S mo negative. Reactant favored siya. Now, if your delta H is exothermic, negative, and delta S decreases, it depends upon the temperature. It depends upon T dito. So, T-dependent siya. It can be nag-increase the temperature or nag-decrease. That will determine if it will be product favored or reactant favored. If your delta H is endothermic and your delta S increases, naging positive, it is also temperature dependent. Temperature dependent. Now, it depends if mas mababa yung temperature or mataas yung temperature. So, this will be your basis also. Now, of course, there are two methods for calculating delta G. The same is true for delta H. We have what you call the free energies of formation, delta GF, which I presented a while ago. So, gagamit tayo ng isang example para maintindihan niyo. Ito yung free energy of formation that we will be making use of. Just like the delta H of formation, ang delta GF of formation for an element is 0. So there are some compounds here with their corresponding delta GF of formation. Tingnan nyo dito si diamond may delta GF, pero si carbon in graphite form 0. Now, for calculating delta G of the reaction, let's have an example. The combustion of acetylene. C2H2, 1 mole of C2H2 plus 5/2 mole of oxygen will give you 2 moles of carbon dioxide plus 1 mole of water. Now, we are going to use the enthalpies of formation to calculate delta H reaction. Given na sa inyo to, delta H of the reaction is negative 1238 kilojoule taken from the formula by Hess law. Now, we also use the standard molar entropies to calculate delta S of the reaction. Ito nakuha rin sa table, pero I was not able to show you anymore the table. We have negative 97.4 joule per Kelvin or negative 0.0974 kilojoule per Kelvin. Now, applying now the equation, delta G is equal to delta H minus T delta S. We substitute now into the formula. Negative 1238 kilojoule, that is the delta H, minus the temperature always at 298. Okay? Unless ito yung hinahanap, that will render. Now, class, magbabari lang tong temperature na ito pag nasa equilibrium na. That means to say, delta G of the reaction is equal to the negative delta G of the reaction. So, negative si delta G natin. Therefore, reaction is product favored in spite of the negative delta S. Reaction is enthalpy driven. Ano naman ang ibig sabihin ng enthalpy driven? Take note. When you say enthalpy driven, delta H is negative. Delta H is negative. Okay? Delta H is negative, less than 0. Delta S also is negative, less than 0 for an enthalpy-driven reaction. Nakuha niyo? Now, you can identify if delta G is spontaneous or non-spontaneous, and you can also identify if it is enthalpy-driven or entropy-driven. You can also identify if it is enthalpy-driven or entropy-driven. Okay, so let's have an entropy-driven reaction. Okay, this is calculating delta G of the reaction in the dissolution of ammonium nitrate. Tutunawin natin si ammonium nitrate by adding heat. Okay, so we will be producing ammonium nitrate in aqueous solution. Now, find out if the dissolution of ammonium nitrate is product favored, or if so, is it enthalpy or entropy driven? Okay, let's find out. So, yung mga delta H, delta S, and delta G, the delta H and delta S were taken from the table already. So, from tables of thermodynamic data, we find change in enthalpy of the reaction equivalent to positive 25.7 kilojoule. Delta S of the reaction is equivalent to positive 108.7 joule per Kelvin or positive 0.107 kilojoule per Kelvin. So, solving it out, we will be able to get that the delta G of the reaction is negative 6.7 kilojoule. Okay? Product favored siya. Kasi negative. But it is entropy driven. Ngayon, anong ibig sabihin ng entropy driven? When you say entropy driven, okay, we have delta S is positive. And, not only that, T delta S, itong expression na to, T delta S, pag minultiply mo ang 298 sa 0.107, mas malaki kaysa 25.7 na delta H. So meaning to say, it is entropy driven if delta S is positive and if T delta S is greater than delta H. Okay? I hope that you note it down already para hindi kayo malito. Got it? Naintindihan nyo? O, Mr. Romano, ano na yung enthalpy driven? Ano yung enthalpy driven? Sabi ko kanina. Hindi nyo sinulat? Enthalpy driven. Ah? Okay, delta H is less than 0 pag enthalpy driven. Delta H is less than 0. Delta S also is less than 0. At relatively low temperature to ha. The entropy driven, delta S is positive. Sa entropy, delta S is positive. And the product of T times delta S is greater than delta H. Ayun. Yan ang basis dito. Pag sinabing entropy and enthalpy driven. Okay. So let's proceed further. Now, gagamit naman tayo ng isang equation for the determination of the delta G of the reaction. We will be making use of the table kanina. So the reaction is the combustion of carbon. Carbon here is in the form of graphite plus oxygen, of course, will give you carbon dioxide. So products minus reactants. Okay, so tignan natin yung delta, yung table. Okay, ano yung product natin, class? Carbon dioxide, di ba? And we have here the delta GF, which is negative 394.4 kilojoule per mole. Ano yung reactant natin? Graphite, di ba? Carbon. 0. Di ba? 0. Oxygen, 0 din. So therefore, we can say that the delta G of the reaction is actually the delta G of carbon dioxide. Okay, so i-substitute na natin dito. The delta G of formation of carbon dioxide, 1 mole, is negative 394.4 minus delta GF of oxygen and delta GF of graphite, 0 then. So 0 plus 0. So therefore, we can say that the delta G of the reaction is equal to the delta GF of carbon dioxide, which is negative 394.4 kilojoule. Note that free energy of formation of an element in its standard state is 0. So the reaction now is product favored as expected because of the negative value of delta G. Now, in here, you cannot predict anymore if it is entropy or enthalpy driven because we use another formula, which is this one. Okay? Questions? Okay. Madali lang naman yung mga problem eh. Ang ano dito, yung principle. Yung principle ang ano i-consider nyo. Okay. Now, ito na yung sinasabi ko sa inyo na if it is in equilibrium, that is from spontaneous, naging non-spontaneous yung reaction, the temperature now is not standard. Hindi na 298 Kelvin or 25 degrees Celsius. Yun ang hahanapin natin. Okay? So, in the reaction of ferric oxide, 2 moles of ferric oxide plus 3 moles of carbon will give you 4 moles of iron plus 3 moles of carbon dioxide. So, the delta H of the reaction as taken from the table plus 467.9 kilojoule. Delta S of the reaction is positive 560.3 joule per Kelvin. Or pag change natin ito sa kilojoule, magiging 0.5603 joule per Kelvin. So, tignan nyo ha, yung value ng delta S. It really depends upon the temperature when it is in equilibrium. Palaging, if it's not at equilibrium, palaging 298 Kelvin ang basihan. And take note of the value, no? Parang very minimal. So, for the delta G of the reaction, we have positive 300.8 kilojoule taken from the table ulit, yung mga GF, delta GF of formation. So now, since delta G of the reaction is positive, it is reactant favored at 298 Kelvin. But at what temperature does delta G of the reaction just change from positive to being negative? Meaning to say, from spontaneous, naging non-spontaneous siya. Okay? So, this is our basis. Ito yung pinaka-reaction natin, equation, which is the basis of solving for the temperature. So, isiset natin yung delta GA of the reaction sa 0. So, ang naiwan na lang sa formula or equation is delta H of the reaction minus T delta S of the reaction. So, ita-transpose natin sa kabila, and then we will get temperature to be delta H of the reaction over the delta S of the reaction. Substitute the values. We got 835.1 Kelvin. That is the temperature when the equation is at equilibrium or the forward reaction goes backward. Naintindihan niyo ba kung paano na-derive tong formula na to? Ha? Naintindihan nyo kung paano na-derive?
Hindi gaano, ma'am. Hindi po gaano makasunod. Pero kaya, ma'am.
Okay, so ipapakita ko sa inyo kung paano na-derive, ha? Okay, since delta G of the reaction is 0, kasi nga at equilibrium, ito yung ano natin, ito yung formula, di ba? So, we set delta G of the reaction to be 0. So, anong naiwan? Ito na lang. Delta H of the reaction minus T delta S of the reaction. Na-transpose natin. Okay, transpose, lipat sa kabila. So, therefore, what will become of our equation? T delta S of the reaction is equal to delta H of the reaction. So, unknown natin yung T. So, T now, lalagay natin sa denominator yung variable that is with your unknown. So, that delta H of the reaction over delta S of the reaction now is equal to T. Okay? Nakuha niya. Sulat nyo na yung formula na yan. Take a screenshot if you want. Okay na?
Wait lang po, ma'am.
Wait lang, ma'am. Wait lang po, ma'am, ha. Ito po, ma'am. Saglit lang.
Okay na po, ma'am.
Okay, so yung susunod na slides natin, parang pinaka-ano na lang, summary. We are done with Thermo Part 3. Pwede na tayong mag-quiz next meeting. So, sana lahat present next meeting, ha? 2 meetings na lang tayo. Isang konting kembot na lang matatapos na kayo sa chemistry. Okay? Basta ang tandaan nyo yung mga principles. The calculations are somewhat simple. Okay? So, notes. A spontaneous change is one that occurs without a continuous input of energy from outside the system. All chemical processes require energy, that is what you call the activation energy, to take place. But once a spontaneous process has begun, no further input of energy is needed kasi nga nakapag-forward reaction na siya. A non-spontaneous change occurs only if the surroundings continuously supply energy to the system. Meaning to say, in the reaction, there's not enough energy. Kulang ng energy. Kaya the tendency for it is to have a backward reaction. If a change is spontaneous in one direction, it will be non-spontaneous in the reverse direction. The first law of thermodynamics does not predict spontaneous change. Diba? Energy is conserved. It is neither created nor destroyed, but is transferred in the form of heat and or work. So change in internal energy, delta E or delta U, is equal to Q plus W. And the total energy of the universe is constant. And the change in internal energy of a system is equal to 0. That is negative delta E or delta U of the surroundings, or change in internal energy of the system plus change in internal energy of the surroundings is equal to the internal energy of the universe. And that sums up to 0. Now, the law of conservation of energy applies to all changes and does not allow us to predict the direction of a spontaneous change. Delta G lang yon. Sa second law of thermodynamics lang. Delta H does not predict spontaneous change. A spontaneous change may be exothermic or endothermic. Spontaneous exothermic processes include the following: freezing and condensation at low temperatures, combustion reactions, oxidation of iron and other metals. Spontaneous endothermic processes include melting and vaporization at high temperatures and dissolving of soluble salts. Naulit to, dapat wala na to. Okay? So here's an example of a spontaneous endothermic chemical reaction. Barium hydroxide octahydrate reacted with ammonium nitrate will give you barium nitrate plus ammonium hydroxide. Now, the delta H of the reaction is positive 62.3 kilojoule. So it means to say it is non-spontaneous. This reaction occurs spontaneously when the solids are mixed. The reaction mixture absorbs heat from the surroundings so quickly that the beaker freezes to a wet block. Okay? I said delta H pala is positive. It's not delta G. Kaya nga spontaneous siya. But it's spent about, nag-absorb ng heat yung reaction. That's why positive ang delta H. Okay, so that sums up the third part of thermodynamics. Are there any questions? Always remember the principles. Kung kailan magpa-positive, magni-negative. Okay? Any questions? Wala? May naintindihan naman kayo?
Meron po.
Baka wala din, ha? Okay. So, quiz tayo ha, next meeting. 25 items lang. 25 lang. Good for 1 hour. It shall be principles and problem solving. Prepare your calculators, scratch papers, all that you need. Formulas. Dapat may naka-ready na kayong formulas. Okay, so Miss Magnaya, nakaabot ka ba?
Yes po, ma'am. Ando po meet, ano po, buong session po.
Ay, oo nga pala.
Na-DC lang po ako kanina.
Si Feria, wala. Ay, laboratory pala ito. Ano? Hindi na niya naabutan yung mga lesson. Andiyan ba si Pineda? Mr. Pineda? Absent din. Manipol? Peterson? Raynon? Sale?
Ma'am Raynon po, ma'am.
Ay, si ano pala to? Pineda. Tapos, si Sale, absent din. Sebastian, absent. Sinsay, absent. At ang daming absent ngayon. Nagpakan, absent. Okay. Yun pa naman yung ano. Okay, the principles, pag hindi mo siya na-take up, hirapan. Okay, if we have enough time, magkakaroon pa tayo ng seat work. Nuclear chem. After the quiz class, we will be taking up nuclear chemistry. And after nuclear chemistry, the last topic will be chemistry of the environment part 1. Konti na lang yon. Wala nang problem solving doon sa ano, sa environment, chemistry of the environment. But magme-memorize kayo. Now, sa nuclear chemistry naman, magbabalance kayo ng nuclear equations. So, please, huwag kayong mag-absent next meeting, ha? Magbabalance kayo ng nuclear reactions and at the same time, you will be learning how to determine the half-life and also what remains when radioactive elements decay. Okay? So please, huwag kayong mag-absent sa ano, sa Thursday next week. Reminding you also of your simulations. Magde-deadline ako ha. Simulations 1 to 8. 1 to 8 na. Kasi dito may mga hindi pa nakagawa kahit isa eh. Ang dami oh. Please, remember class, pag hindi nyo nagawa itong simulations nyo, hindi kayo bibigyan ng incomplete. Iko-compute namin kung ano yung meron. You will be only given incomplete grade if you were not able to take the final exam. Kaya gawin nyo na as soon as possible itong simulations ninyo.
Ma'am?
Yes.
Yung mga simulations po, ma'am, wala na pong madadagdag doon na?
Meron nga, 8 lahat.
8 pa ba? Okay po.
8 lahat. Initially, 3 lang yung in-upload ko. Ngayon, 8 na. The last part will be environmental. Yung last topic kasi natin is about chemistry of the environment. So yung last simulation nyo will be environmental impacts of coal power plants. Related doon sa topic natin sa chemistry of the environment part 1. Simple lang to, 50 points lang. Yung number 8 is about nuclear chemistry. Number 8 is about nuclear chemistry. Natapos na nga ni Mr. Borbor eh. Mr. Coronel, hindi pa nadidiscuss pero nagawa na nila yung simulation. Tama ba ako, Mr. Coronel? Mr. Coronel?
Ma'am?
Nagawa mo na rin yung nuclear chemistry. Ano? What's happening inside the nucleus? Tama ba ako?
Yes po.
Okay, 50 points lang, 90 points yon. Yung calorimeter, 80 points. So, sa number 8, that will be environmental impacts of coal power plants, 50 points lang yon. Okay, so please, magde-deadline ako until Tuesday. Tapusin nyo na lahat ng simulations nyo 1 to 9. Or, basta matapos nyo lang sana yung 1 to 6. Kung hindi nyo pa kayang gawin yung 9, yung 7, kasi it's all about nuclear chemistry. Kahit 1 to 6 man lang sana ang matapos nyo until Tuesday. Okay, magdi-deadline ako dito ha. Daming holidays hindi kayo naggawa. Pag hindi nyo nagawa ito until Tuesday, magkakaroon ng deduction sa points.